Hello, my name is Carlyle, and this is my presentation for Lab 2. In this lab, we learned the physics behind the motion of a falling object. As you can see in the video, an eraser was dropped. Using this video, we will measure the effectiveness of various prediction models using different force values. Newton's second law is F net equals m times the change in velocity over time. Essentially, this is the same as the momentum principle, which is P equals m times v. This concept will be very important in this lab. The goal of this lab is to be able to predict the future of where an object moves if it is dropped and therefore experiences a drag force. In regards to observations, we should observe that the eraser's velocity will increase as it falls. Moving forward, we will examine two different models. First, we will look at one that only experiences gravity and does not experience a drag force. Second, we will examine a model that includes both gravity and a drag force. This will affect the net force, so we will be assuming that with no drag, the net force is 0, and including the drag force, the net force will not be equal to 0. This lab connects to the physics fundamental principles by using the equations on the screen. These include Newton's second law, momentum principle, and the net force equation. As always, the net force equation can be explained as the sum of the forces in each direction. In this scenario, the net force equation is the force of gravity minus the drag force. The original model for prediction, which is shown in the next slide, did not include drag. This model used GlowScript code by predicting a net force of 0 with the assumption that the change in velocity is also 0. However, the second model considered both drag force and the change in velocity. The new model was used for the prediction with drag because it demonstrates the effect of drag force on the eraser, which results in the direction always being opposite of the object's motion, and the magnitude is always proportional to the square of the object's speed. This is turbulent drag. This model shows the tracker values, which is the observed values, and both the predicted values with and without drag force. Please notice the legend on the side. After observing this graph, we can determine that the predicted values with drag is more accurate and closer to the observed values than the values with only gravity. Some possible sources of error in my experiment include accidentally giving the paper initial velocity by throwing it, or dropping one end of the eraser before the other, making it uneven. If I were to conduct this experiment again in the future, I would have the eraser drop for a longer period of time, start analyzing longer after the drop, or drop a different object that would be more efficient, such as a ball. These would all make the observed values and predicted values more similar. The velocity versus time graph shown here shows a consistent velocity for the predicted value without drag because the force is assumed to be constant. However, the other values are not constant because the drag force changes as the eraser continues to fall. The lines should not be as wavy as they are, but this can be a result of the errors I previously mentioned, as well as errors while using the tracker software. There's a terminal velocity where the drag force points up at the same rate that the force of gravity is pointing down, for both the observed and predicted values with drag. At terminal velocity, the object's change in velocity is 0 because the forces balance out, which also means that the net force is 0 because of the net force equation that I previously mentioned. If the eraser were thrown down instead of dropped from a 0 velocity, the terminal velocity would be different than our observed values because there would be an added initial velocity. There would still be a terminal velocity acting on the object, but it would be different because of the net force equation I mentioned earlier. The models here show that when the object is thrown downwards instead of dropped, it has an initial velocity, so the object will always have a greater velocity at each point in time than if it were dropped from rest. These graphs demonstrate that, because even though they may look similar, the axes show that they are very different. As you see in the second graph, which is our what-if graph, it has an initial velocity that is greater than 0. Overall, this second lab shows the importance of Newton's second law, the momentum principle, and the fact that drag force does indeed exist. Thank you and have a wonderful day.